Hello everyone. Let's deal with this very quickly. K to the power of 3 equals 27 over 8. And we are going to solve this completely. What do we do? If you take the cube root of both sides, it will give you only one solution. And we need more than one solution. So what do we do? Now this is K to the power of 3. Let me cut it like this. K to the power of 3 being equal to 3 to the power of 3 over 2 to the power of 3, right? Now, since the powers are the same, we can combine this. So we have k to the power of 3 to be equal to 3 over 2 to the power of 3. Now, let's bring this to the left. So we have k to the power of 3 minus 3 over 2 to the power of 3 now equals 0. So let's recall this. If you have a to the power of 3 minus b to the power of 3, this is a minus b into a squared plus ab plus b squared, right? This is what we have. Now, if we're going to go by this, our a is now k and our b is 3 over 2. So let's substitute into this. In place of a minus b now, we'll have k minus 3 over 2. Close that. Then here we have k, there's a square on it, plus a is still k, multiplied by b is 3 over 2, then plus we have b squared, which will be 3 over 2 to the power of 2 because of the square on it. And everything is equal to 0. Okay, so to continue with this, we have k minus 3 over 2. Then here we have k squared plus k times 3 is 3k, then over 2. We have 3k over 2, then plus 3 squared is 9, over 2 squared is 4. Then we close this and equate to 0, right? Okay, I think I should close the bracket well. Okay, should close the bracket very well. So from here, let's continue. We can say that either of these is equal to 0. So I'll pick the first, k minus 3 over 2 is equal to 0. Now let's clear out the fraction. 2k minus 3 is equal to 0, meaning that 2k is equal to 0 plus 3, and that is 3. So that our k is equal to 3 over 2. So we've known our k. Now, let's get the other value from here, where we had k squared plus 3k over 2 plus 9 over 4 equals 0. The next point is to clear out the fraction as well. The LCM is 4. 4 times k squared, that will be 4k squared, plus 4 times this, it will be 2 multiplied by 3k, because these 2 will cancel, will go into the 4 2 times, right? Then plus 4 will cancel itself from here, so we have 9. Then we equate this to 0. Now 4k squared plus 6k plus 9 is equal to 0. This is now a quadratic equation, and we can solve this by using the formula, right? Okay, so this is the equation. Our A is 4, B is 6, and our C is 9. The formula is K equals minus B plus or minus B squared minus 4AC. Everything is over 2 times A. So we already have our ABC. We'll now substitute straight into the formula. Okay, so K now will be, in place of minus B, we'll write minus 6 plus or minus B squared will be 6 squared minus 4 times A is 4 and C is 9. We divide by 2 times 4. Now K is equal to minus 6 plus or minus 6 squared is 36 minus 4 times 4 times 9 is 144. Then we divide by 8. K now will be minus 6 plus or minus, subtract this, we have minus 108, and that is over 8. What do? K is minus 6 plus or minus, we have square root of 108 multiplied by square root of negative 1. Then we divide by 8. Now the next thing we will do is to simplify root 108. K will now be equal to minus 6 plus or minus square root of 36 times 3, then times square root of negative 1 over 8. Our K now is minus 6 plus or minus 36. Here is a perfect square, and the square root is 6. Then we have root 3 multiplied by square root of negative 1 is I. Then we have this over 8. We can rearrange this, so we get K equals minus 6 plus or minus, we have 6 times I, 6I. Then we have root 3 divided by 8. Right, 2 can go into them, so K will be 2 into that is minus 3 plus or minus 2 into that is 3I. Then we have root 3, then divided by 2 into 8 is 4. So from here we have two solutions. The first is K equals minus 3. We use plus first, 3I root 3 over 4. And then the second, or we have minus 3 minus 3I root 3 over 4. So from here we have the two solutions from here. And remember we had another solution before, which is K equals 3 over 2. This is the real solution, while the last two are complex solutions.